The Richter scale was developed at the California Institute of Technology in 1935 by seismologists Charles Francis Richter and Bino Guttenberg. At the time, Richter was researching earthquakes in California and needed a simple and objective way to accurately communicate the size differences of earthquakes, as at the time the Mercalli scale, which relied on observations of the severity of damage created, was the only way of measuring an earthquake. The Richter scale was far more scientific and modeled after the stellar magnitude scale, which astronomers use to determine a star's luminosity. The Richter scale obtains the amplitude created by a device that measures ground vibrations, called a seismograph, and uses logarithms to obtain a simple number that could be compared to other earthquake sizes easily. The Richter scale was only reliable if the measurements were taken 600 kilometers or less away from the epicenter of the earthquake, so Richter and Gutenberg updated it. In 1972, the moment magnitude scale was created, which was more accurate and is currently used today.
Here is the equation for the Richter scale. M is magnitude, I is intensity, and S is standard intensity. M for magnitude expresses the relative size of an earthquake in a user-friendly output units of magnitude. This is a purely empirical measurement, not directly connected to a physical quantity like energy, but it does use an absolute value for a real number as its input. I for intensity is the peak amplitude of the quake's ground motion on a Wood-Anderson seismograph used in 1935. Conceptually, it's a physical measurement of a seismometer's maximum deflection from zero, given in thousandths of a millimeter. S for standard intensity is a calibrating value. That's an arbitrary amplitude used to adjust for distance. For 100 kilometers, the initial value of 1 returned an M of 0 for the smallest recordable quakes, 3 for the smallest felt quakes, and 5 to 7 for some of the largest that might be encountered. The logarithm to the base 10 gives how many factors of 10 are in the amplitude after calibration. This causes every 10-fold increase in intensity to return a magnitude that is 1 greater. Consequently, an amplitude of 100 millimeters gives a magnitude of 5, while an amplitude of 10 millimeters gives a magnitude of 4. 10 to the 5 is 10 times greater than 10 to the 4.
The Richter scale measurement is given by the equation m equals log 10 brackets I over s, where m is equal to the magnitude, I is equal to the amplitude, and s is equal to 0.001 of a millimeter. Therefore, if the amplitude was 0.001 of a millimeter, the equation would be log 10 1, which is equal to 0 on the Richter scale. Going up in units of 10 will go up by 1 unit on the Richter scale, as shown below. All seismometers used to measure the Richter scale are calibrated to account for external factors such as distance from the epicenter of the quake. Another insight into the Richter scale is that the magnitudes produced by the equation can be reversed and put back into the original input of the intensity, allowing seismologists to collect large tables of earthquake magnitudes and transmit them to other colleagues without any loss of data.
The Richter scale's output number is small and intuitive, easy enough for the public to understand, yet complex enough for specialists to utilize effectively. It has obvious applications in the study of natural disasters, helping researchers to identify dangerous regions and trends. As Bolt notes in his Earthquakes 2006 Centennial Update on page 166, magnitudes of previous earthquakes are used in an approximate way to predict what the greatest acceleration of the ground shaking may be in an earthquake at a site of an important structure. The information is then used by the engineer to design a structure that will withstand such strong motion. While the Richter scale, originally referred to as local magnitude, is not used as commonly today as it once was, Stein and Weissession note, local magnitudes are sometimes still reported because many buildings have resonant frequencies near 1 Hz, close to that of a Wood-Anderson seismograph, so local magnitude is often a good indication of the structural damage an earthquake can cause. The Richter scale also has its uses in the field of nuclear weapons testing. This is noted by Bolt in the aforementioned Earthquakes 2006 Centennial Update, where he states the following. Research has indicated that comparison of different kinds of magnitude is one of the best ways to distinguish between an underground nuclear explosion and an earthquake due to natural causes, thus assisting in the monitorization of the nuclear test ban.